normally a job like this would probably, when it came back from stress relief, would end up on one of the 3D machines to semi the top or finish the top or do whatever they'd like to do. So on that machine, in our case here, I have a list of the different machines that this company has. I'm going to pick a 3-axis vertical machine, and I'm going to tell it that I'd like to use it. I need to do a setup to tell it where, what orientation is the block, so I can move the block back and forth. So if I need to turn it around for the machine or turn it sideways, whatever I need. If I want to slip it up on one of its sides, I can stand it on end or I can put it on its back. However I'd like to do it. In this case here, we'll keep things pretty simple. I'll just leave it as it came. I'd like to change my origin point, so I'll put my XYZ 0 up in the corner. Everything else looks okay. And what you'll see is as soon as I do that, each one of the holes now actually has all the operations and tooling that are required to be able to drill this. So rather than monkey around with this a little bit, I think I'll just tell it to drill it. If I say drill all, okay, what it'll do is from the top, it'll show me all the different types of holes that it sees, and you'll see that some of them here say the name of the pattern that it found. Some of them say the name of the pattern with a little bracket of REV, which is telling us that some of the stuff that we're doing, we need to be able to machine from both sides, as I previously would have mentioned. It's just creating the tool paths right now, so that just take a second to create them for this side of the job. So if we have a look, you can see here on the guide pins, it went ahead and it did the first drilling, the second drilling where it couldn't reach, and then it put a chamfer around the top. For any of these ejector pins, it automatically helicaled down from the top till it got to a flat spot, because we need a flat spot to be able to drill it. So here we have the helical, and here we have the drill from the top to make sure that we have an accurate location, and we'll do the clearance of the ejector pins from the back. Same thing with the nozzle drops. Here we did a kind of a ream size with the helical to put it into position, followed by the reaming. Right, so there's the reamer that goes in behind it to make sure that everything is there. We have tip compensation for everything so that I can make sure that the helical goes deep enough that the reamer doesn't hit it. There's all kinds of controls that I have over top of that. To be able to do some more with this, what I'd like to do is just pop my panel back out here a little bit, and I'm going to make a process list, and we're going to call this guy setup 1, and maybe I'll put dash sigma, which is the name of the machine, so that I know what I can do, because this will track through several different machines to be able to do what we want. I can take all of the programs from this side. If I want to simulate some of them, I can do that. I can pick one and tell it to simulate, right? We'll just take this guy and click on simulate, and you'll see that everything is automatically optimized for rapids. It'll go through all of the nozzle drops with this particular program, and it'll move its way through and do what it needs to do. Once you've determined that a sequence is correct for a certain type of pattern, and it's been tested out on the machines, everything's proven out, it will do all the automatic depth detection, so we don't have to worry about the depth. It will warn us if the tooling is too short. There's all kinds of collision detection inside of the system to make sure that we don't collide. We have another check to make sure that we don't actually violate any of the surface data of the model. Everything is checked and checked and checked to make sure that everything is as it should be.